So welcome everyone. Thank you for taking the time out of your day to come to my session. I really appreciate it. As Dave said, it's getting started with data modeling. And a quick bit about me. My name is Angela Henry. I live in High Point, North Carolina. I am a solution architect at Blue Granite. I am a data platform MVP. I'm also a Microsoft certified trainer. I am on Twitter. My handle is SQL Swimmer. And from the picture, you can see that I'm a swimmer, but I'm also a coach and an instructor. And I'm going to take 20 seconds to get on my soapbox here to say that if you don't know how to swim, please learn. It is the only sport that can literally save your life. And if you think as an adult you cannot learn how to swim, you are absolutely incorrect, because there are instructors like myself who are specially trained through US Masters to teach adults how to swim, because it's very different than teaching children how to swim. So there's my soapbox. I'm putting it away and we're going to keep going. So now that you know a little bit about me, I want to know a little bit about you so that I can understand the audience. You know, when we used to be able to do this in person, I could have people raise their hands. We can't do that now. So if you could just put it in the chat, that would be wonderful. So are you a developer? Are you a DBA? Are you an analyst? Or are you something I didn't mention, some kind of IT manager? I've had executives show up, all kinds of things. So, all right, we got some QA folks, a baby analyst. Do you analyze babies, Brenda? Or are you just starting with being an analyst? Very nice. All right, awesome. Good stuff. Well, today, what we're going to talk about is, first, we're going to define what data modeling is. And then we're going to talk about the different benefits that you can get from data modeling. And then we'll go through a really quick example of how to get started with data modeling. So let's just dive right in and define data modeling. We're going to do a little bit of a history lesson here when it comes to databases. So we started out with these navigational databases back in the 60s, and then we progressed to relational databases and then to analytical databases. So we're going to talk about these just a little bit, not a whole lot. So those navigational databases. So these are, they required kind of this manual navigation via linked data sets in a large network. So think COBOL. And this is kind of how databases really started out. They weren't super efficient. They used lots of space. And that's when relational databases came along. Thanks to E.F. Codd. He was a guy that worked at IBM back in the 70s. And he said, those navigational databases, they just don't do it for us. We need a better database. We need a better way of doing this. So one of the things that those navigational databases did is that they stored data the same piece of data multiple times in different places. So that's where E.F. Codd says, you know what, we need to normalize this. We need to stop saving all of this information in various places. So we're going to highly normalize it. And we're going to optimize it and make it so that it's really super efficient for those highly transactional systems. And we are going to use this language, this structured query language, in order to pull that data out of those databases. And in doing all of that, it made those databases really optimized for write operations. So think of things like point of sale systems or manufacturing systems, credit card processing. Those are all relational databases that are highly transactional and really focused on write operations. Well, you know, that was great because we had all of these really fast transactional databases, but when we needed to report on anything out of there, it was really cumbersome because it was so highly normalized. So that's when we come to analytical databases. And these databases are denormalized. So now we're storing repeating values, and we are trying to bring it all together and one of the great things about analytical databases, and most of the analytical databases that are out there, is that they're optimized. They use columnar optimization. So if you have the same value in a single column 20,000 times, it will only store it once, and because it's compressing based on the values in the column. So we got some really good stuff there. These are typically optimized. It's not a highly transactional system. You're loading data on a regular cadence. You're loading it in batches. So think of like a data warehouse where you load everything once a day or once an hour kind of thing. And these databases are typically laid out so that you can put a semantic layer on top. And then you can use those analytical languages like MDX or DAX to pull data out of there. And these databases are really optimized for read operations, because we don't need to, we're not in that transactional position where we need to write that data. Now we're trying to get that data out of there. So these are really optimized for read operations. So the most common use cases for data modeling that you're going to come across are typically for those transactional databases or those analytical databases. And what we're going to talk about today is analytical databases. And when we talk about modeling for analytical databases, that's called dimensional modeling. And you'll see why when we get into this a little bit more. So when we talk about dimensional modeling, there are two really common methodologies out there. There's the Inman model, and then there's the Kimball model. And this can be a dividing philosophy for some folks that are out there. Kind of like, do you mix peanut butter and chocolate together? Some people say absolutely, other people say don't do it. I am very pro Reese's peanut butter cup, just so you know. All right, so what about that Inman method? Well, that Inman method, it takes a top-down approach. And what I mean by that is that it looks at the company as a whole and tries to build out this entity relationship-oriented diagram to make things relate together. And it's still in that very, very highly normalized method. So you're only storing a single piece of data once. You're not storing it multiple times. So that's the Inman method. And then there's the Kimball method. And this one is a bottom-up approach. And what we mean by that is, instead of looking at the whole organization, this is instead business process oriented. So you look at a specific business process, and then you denormalize that, and you go ahead and you repeat values within your structure, and it makes for a much faster access to your data, and it's a lot less complex to be able to pull that data out of there. Now, if you're going to be using any of the Microsoft analytical tools, the Kimball methodology is the best one for the Microsoft analytical stack. And when I say that, I'm talking about Power BI, I'm talking about analysis services, whether it be on-prem or Azure, and same for if it's tabular, whether you're in analysis services, Azure analysis services, or on-prem, and with multidimensional as well. And that is going to be the focus of what we're going to talk about today, is really that Kimball methodology for dimensional modeling and how you would get started with that. So whenever you start something, you always have to learn new vocabulary. So some of the vocabulary words that we're going to learn, we're going to talk about facts. We're going to talk about dimensions. We're going to talk about a star schema. We're going to talk about granularity. We're going to talk about surrogate keys, and we're going to talk about Sentinel values. So those are our 6 vocabulary words that we are going to define and then learn how to use them and put them together in this presentation. So let's start with facts. Facts are typically those long, skinny tables. They don't have a lot of columns in them, but they have lots and lots of rows, tens of millions of rows, sometimes even billions of rows. And the facts are what describe our business process. So, and facts can have, take several different forms. So they can be additive, which means you can sum it up across any of the dimensions that are associated with a fact. And we'll talk about a dimension in just a second. So think of things like your sales amount, or your purchasing amounts, or attendance, something that you're trying to measure. Next is semi-additive. So these are things that can be summed across some of the dimensions, but not all of them. So think of this as like balance amounts. At the end of the month, when you get your bank statement, that's a balance amount. So you don't want to add those balances up to be able to get your total, because it's kind of a running balance. Next, you can have non-additive facts. And these are things like ratios or percentages. It's better to store the actual values than to compute that ratio, but sometimes you don't have that option. So just know that if you are going to be storing a ratio, that's a non-additive fact. And then lastly are the factless facts. And this is where you're just merely recording something that has happened, where things come together at a moment in time. So there's nothing other than you're trying to record that occurrence happening. That's kind of a factless fact. So those are our facts. They're the long, skinny tables. Then we have dimensions. Dimensions are our short, fat tables. They typically have a lot of columns in them, but not a whole lot of rows. And the dimensions are what are typically going to be used to slice and dice your facts. I want to see my sales by store, by product, by plant, by state. So anything that precedes the word by, that's typically going to be your dimension. And with dimensions, we have a couple of different kinds of dimensions. We have conformed dimensions. Now, when we talk about dimensional modeling in the Kimball method, we talk about business process oriented. Well, we can have some dimensions, which are describing our facts, that are common across all of our business processes. Those are our conformed dimensions. They can describe, a single dimension can describe multiple business processes. So like a date or a product, that's going to be the same throughout our organization. Next, you have degenerate dimensions. And this is nothing bad. I hate this word, but it always makes me smile when I see it, because it's just like, oh, that's just such a horrible word to use. But what this really means is that sometimes you have no context for something other than its own existence. An example of this is when we talk about purchasing and invoices. You're going to, when you get into the dimensional model, you're going to be pulling that apart, and then sometimes a lot of what you're left with is just one thing. So like an invoice number, that is something that is common across all of the lines that are associated with an invoice, but by itself, it doesn't really have any value. So instead, we're going to add that invoice number to our fact table, and we're going to call it a degenerate dimension, because it's really a dimension that is sitting within our fact table. And that sounds kind of confusing, but it'll make more sense when we get to kind of looking at this a little bit later. And then next, we have junk dimensions. And does everybody have a junk drawer at home? That I have a junk drawer, and you just throw all the odd loose ends in there. That's kind of what a junk dimension is, where you have like these kind of onesie twosie attributes that you want to measure, but you don't want to create a dimension for each one of those. So what you do is you combine them all together and put them in a junk dimension. And typically what you're going to do is you're going to create a Cartesian product, where you're basically going to create every single version of the matching of the different attributes together. And that's what you're going to put in your junk dimension. And then Lastly, we have slowly changing. Now, when we talk about dimensions, they're the things that are describing our business process. But sometimes those things can change, like a customer. A customer can move. Well, do we want to be able to track whether that customer is moved? Maybe, maybe not. Depends on the business process that we're trying to model. So that's where the slowly changing dimension comes in, is whether you want to track the changes to those dimensions or not. So that's what we mean when we talk about slowly changing dimensions. Whoa, I'm not sure exactly what happened there, but it just kind of went really wonky on me. So, all right. So those are dimensions. The next thing is the star schema. That's what we're going to talk about now. And why is it called a star schema? Well, facts usually are in the middle of our star, and then we have dimensions that are related to our facts, and they all point directly to our fact. So when you lay it out, it typically looks kind of like a star. That's why they call it a star schema. And this is my ultimate star schema. The head of that dandelion is your fact, and all of those little seed things are the dimensions. So they don't talk to each other, they only talk to the fact. And that's going to be important when we talk about snowflaking. All right, that's the star schema. Let's talk granularity. Granularity is probably the most important thing when we talk about dimensional modeling, because you have to define this before you can do anything else. And what this does is it establishes exactly what is going to live on that single row in that fact table. And your future self will thank you if you think about and you really investigate and define what that granularity is before you start doing any work. Really, it controls the scope of data that's going to live in your fact table. And you want to focus on the lowest level that's possible. So when we talk about measuring things by time, is our lowest level going to be by year? Is it going to be by quarter? Is it going to be by month, week, day? That's what we need to figure out. We want to get to the lowest level we possibly can to make sure that we can roll things up. It's always easy to roll things up, but we can't always unfold things once they're rolled up. So you want to focus on the lowest level. And then the second thing about granularity is you don't want to mix granularities. So in your fact tables, you are, like I said, you're defining the scope of the data that lives in there. So if you have a fact table about sales, they typically do that on a daily basis. You don't want to have daily sales mixed in with monthly sales. That's mixing granularity. All right, that's granularity. Now, let's talk about surrogate keys. So they have no inherent value, and it's kind of a fancy way of saying we made it up. And what this is it's a way for us to allow for those repeated natural keys within our data, if we're pulling from multiple systems, to reside in the same place without having any conflict. So if you are pulling data from multiple systems, multiple point of sale systems, one point of sale system might have store IDs as one thing, and another store uses a different methodology. But sometimes you have overlapping values, but you still need to preserve what those original values were to identify those stores. So that's where you come up with a surrogate key. And typically this is something that's going to be, and of course my phone is going to ring because it never does until I get on a call. So hold on a second, turn that off. So my ADD is kicked in. So where was I? Talking about surrogate keys and oh yeah, so mixing values. So sometimes you need to preserve those individual values, but you still need a way to uniquely identify the items within your dimensions. So those are typically going to be something like an auto number field, so a sequence or an identity column, depending on what relational database system you're using. It's going to be called something else, but typically it's a number, an integer or a big integer, something like that. And again, it has no inherent meaning. It's just a way for us to allow for those repeated natural keys without having any conflict. And then the last vocabulary word for today are Sentinel Values. And Sentinel Values, it's basically, we're going to be talking about substituting when we are missing values. And they need to be agreed upon ahead of time with your business people. And what this really does is it allows you to have consistency of values across your model. Now, there are two different kinds of Sentinel values. You can have the one for the unknown record. So sometimes when you're processing stuff for a data warehouse, you're pulling information in, but you get information about your business process, like you have a brand new plant that has been added if you're in manufacturing, but that plant doesn't exist in your plant dimension yet. So you still have to be able to identify the data, so you give it an unknown record. So that's one use case for Sentinel values. And then the other one is when you just have missing values completely. So if you're, gathering information on people, you first name, last name, address, city, state, all that kind of stuff. Sometimes missing data, you just want it to be missing, but other times you want to know that it was missing, but you need to be able to identify when it's actually missing or when it wasn't supplied. And this is when you can do things, you substitute things like the word unknown or NA for a value, so that you don't have null values within your data model. So those are our Sentinel values. And that is your quick history and vocabulary lesson for dimensional modeling and data modeling. Do we have any questions about data modeling before we jump to talking about the benefits? And I'm going to take a drink while I wait to see if there's any questions.
Angela, I have a general question in the Q&A here.
Sure.
Do you have any good books to recommend on this topic?
I absolutely do. I'm so glad you asked. Ralph Kimball, who is kind of, I call him the godfather of modern dimensional modeling. He has a great series of books. It's called the Data Warehouse Toolkit. You can find these on Amazon. They also have a lot of information available online. Just Google Kimball methodology, and you'll find a whole bunch of stuff. And again, a lot of it is available online. But the Data Warehouse Toolkit is one I actually do keep this right here on the side of my desk within arm's reach for whenever I run into situations where I'm not quite sure how to model that. So yeah. Any other questions?
That's all I see so far, but everybody please don't hesitate to drop those in chat and Q&A, and I'll make sure to get those to Angela.
Perfect. All right. Well, let's go ahead and continue, and let's talk about the different benefits that you can get from data modeling. The first one that you're going to get is flexibility. And the biggest flexibility that you're going to get is that you're going to be able to support different granularities. Now, I know I said earlier that you don't want to mix granularities in the same table, but you can mix granularities in the same model. So a really good example of this is if you have daily sales versus monthly sales. Depending on, if you have multiple systems coming in, sometimes you may not be able to, some systems come monthly, some come daily. So you can separate those out. Another good one is budget versus forecast. A lot of times those are done at a monthly granularity, where your sales are done at a daily level. So flexibility is a really good benefit when you do dimensional modeling. It's a little bit more intuitive. You're going to be using the business vocabulary when you're defining your tables and your columns. And it's going to be the friendly names that your business people are used to. And then the last key thing here is that your keys are hidden. And this is very important because keys mean nothing to your business people. That's really just a way to be able to uniquely identify your data. So your keys, you keep those hidden. And then, oh, I lied. There is one more thing. You only have relationships between facts and dimensions. You don't have relationships between dimensions. It's just between facts and dimensions. So it makes it much easier. Remember that star schema where the stars, the points of the stars were the dimension and everything pointed to the fact table. So it's much more intuitive. Faster processing. I alluded to this a little bit earlier with that columnar compression and columnar databases. So you get much faster processing than you typically do when you're trying to pull data out of a relational system. And your code is going to be much less complex because we have denormalized that. You don't have to go to 15 tables to get to the answer to something. It's typically you're going to end up with like 2 tables to be able to write code to pull that data out. And here's a quick example on the left-hand side. And I know this is kind of small, but you can see where I've got 1, 2, 3, 4, 5, 6, 7, 8 tables in a kind of header detail where I'm trying to pull information out and then get additional attributes for that. When I write this code in an analytical database using dimensional modeling, I just have 2. I've got 2 tables that I'm going out to pull that data in because we've denormalized it and we've made it, added those repeating values in there. So we don't have to go to all these different tables. So it's a lot less complex when you're trying to write code against a dimensional model. And those are kind of the benefits of dimensional modeling. Do you have any questions on the benefits of dimensional modeling? I'm going to take another drink while we wait. All right, I'm going to keep going. We've got about 15 minutes left. So how do you get started with dimensional modeling? Well, typically it starts from a relational database. You've got some transactional system that you want to be able to write reports on or analyze that data with. And this is what your typical relational database diagram looks like. And that can be overwhelming. So we need to be able to get it from that relational design into that analytical, that dimensional model. So how do we get started with that? Well, the first thing that we need to do is you need to select your business process. So remember, with that Kimball methodology, we start with a single business process and go from there. In the Inman methodology, you look at the business as a whole. So this is one of the reasons why I really like the Kimball methodology, is because it really kind of creates that hyper focus on a single business process, and it makes it much easier. Next, declare your grain. So remember, I said granularity is super important and you have to do this first. Well, you do it first right beside or right behind defining the business process that you want to analyze. Identify those dimensions. Figure out the who, the what, the where, the when, the why, the how, those descriptive or qualitative attributes that you want to be able to measure things by. And then define the facts. What are the things that you're trying to measure in that business process? So that's how you're going to get started. So first of all, select your business process. And these are those operational activities that your organization performs, such as taking an order or processing an insurance claim, registering a student for class, those kinds of things. And those business processes will eventually become your facts, but first you have to figure out a specific business process that you want to analyze. Declare the grain. What will a single row in my fact table represent? The sale of a product on a date to a customer in a store by a salesperson. So we've established our grain. That's exactly what's going to be contained in a single row of our fact table. We've declared our grain. Identify your dimensions. Again, this is kind of the who, what, where, when, how, and why. These are the descriptive or kind of the qualitative attributes that you're trying to look at as part of your business process. And think of these, this is typically what you're going to want to like filter or group by. So the sale of a product on a date to a customer in a store by a salesperson. So we have our product, a date, a customer, and a store, and a salesperson. So we've got 5 dimensions there. So our customer is who. We've got a product, that's our what. We've got a store, which is where. Our date, which is when. And our salesperson, which is how. So, all right, we're defining our dimensions. We've identified our dimensions. Now we need to identify those facts. And really, you just have to stop and ask yourself, what are we trying to countermeasure? So in our situation, let's say, what are our sales? That's kind of an obvious one. Well, how many products did we sell? How many customers do we have? What's our sales margin? Those are your facts. Those are the measures that you want to be able to figure out and analyze about your business process, which is your fact. So let's put this all together. So we have a sales table, and we have the number of units sold here. We've got a customer, we've got a product, we've got a store, we've got the date that it was sold, and we have the salesperson who sold it. So now that we've modeled this out, which one are you going to use? I don't know about you all, but to me, it's kind of a no-brainer, and I'm going to go with the one that's on the left-hand side, because that looks a whole lot easier to be able to pull data out of than that relational schema that's on the right-hand side. So in short, you want to star schema all the things if you are going to be using the Microsoft stack of analytical tools. You're going to get the best performance because that's what those tools were designed to consume, is something that's in a star schema. So simply put, what do you want to count? Sales, widgets, occurrences. These are your facts. And how do you want to count it? By date, by product, by customer, by store. These are your dimensions. So what do you want to count? How do you want to count it? That's how you come up with your dimensional model. So do we have any questions on, how you would actually go about doing that? I'll take a drink while I wait for. All right, we're going to keep going. I have one last concept I want to introduce you to, and it's called snowflaking. And whoops, it's called snowflaking. There we go. And what that means is it's dimensions that describe other dimensions. And remember, we only want those relationships between facts and dimensions and not between dimensions. And as a former DBA, this was like the hardest habit for me to break because I wanted to just normalize out absolutely everything. And repeating values in rows are not a bad thing when we talk about the analytical database, because again, we've got that columnar compression that's typically going to shrink all of that down. So it's not going to be this big, we're not wasting storage by storing the same value more than once. So let's take a quick look about what I'm talking about. So in my example here, I've got my fact table. It's a sales. I've got my product table. It's got some information about a product. I've got my dimension table or my segment table, and then my category table. Those are also dimensions. So my product key goes to my fact table, and that's how those two are related. From my segment to my product, again, they're related on that segment key. and my category key, same thing. So this is how these are all connected and how we could write all of this. But we don't want those two segment and category dimensions, because those two dimensions are describing the product dimension. And we don't want that. That's snowflaking. So what we're going to do instead is we need to eliminate that segment and that category table. So first thing we're going to do is we're going to take those values from the segment table, the segment name and description, and we're going to add them to our product table. Once we've done that, we can go ahead and get rid of that segment table. And then because we no longer need to connect to that segment table, we can get rid of that segment key. So now our product dimension has the product name, product description, segment name, and segment description in there. And then we can do the same thing for category. We can take the values from our category, which is our name and our description, add those to the product table. Now that we've got them there, we can go ahead and get rid of that category table. And then lastly, all we need to do is remove that category key from our product dimension. And just like that, no more snowflake. And that's just, it's a very simple example, but that kind of gives you an idea of how you would go about doing that. And snowflaking is bad. Now, I say this, there are some exceptions to that rule, because, you know, as with most rules, there are exceptions. But for the most part, snowflaking is bad unless you have a very specific purpose to add that additional dimension that describes another dimension. So do we have any questions from any of the folks out there about how to get started from a relational model and take it to a dimensional model? I'm going to grab another drink here.
Angela, I wanted to ask, for clarity's sake, do you see that this analytical paradigm is going to eventually replace the relational model, or is it a kind of an enhancement to it?
No, that's a really great question. So is the analytical database going to replace the relational database? Absolutely not. They are two separate things. They serve two separate purposes. That relational database is there for those highly transactional systems. They're optimized for writing super fast. So again, remember, think of that point of sale system or in manufacturing, those ERPs where they're constantly recording information. It's super fast credit card processing, highly transactional. Whereas those analytical, that is what is created. Think of like a data warehouse where it's not highly transactional. Data is loaded at a specific cadence, whether it be daily or monthly or weekly, so that you can actually analyze those systems. And the whole reason that the analytical databases came about is because trying to write queries against those relational or highly transactional systems was very complicated. It put a load on the system because they weren't optimized for reading that information, only for writing that information. So the analytical database is more just kind of that's the next layer on top of that to be able to do any reporting or analytics on top of your relational data. Does that make sense?
Yes, thank you. So I wanted to direct your attention quickly to the chat. There was a question for clarification. The last diagram was turning a snowflake model into, what was it called? Oh,
so snowflaking is kind of, it's a concept. So remember our, let me bring this back up, get to the right. So when we look at our star schema, our facts are in the middle and our dimensions are only related to the fact. They're not related to each other. It looks like we've got about 5 more minutes. That's perfect timing. None of those dimensions are related to each other. They are only related to the fact. And when we look at snowflaking, snowflaking is when, if I can find the right example, is when we have dimensions that are describing other dimensions. So it's more kind of a concept. So what we're really doing when we get rid of that snowflake is we're creating a well-formed dimensional model. Because remember, I said snowflaking is bad, but there are some exceptions. So that's kind of, you want to be able to create that well-formed dimension, but well-formed model, but sometimes you can't always do that. So does that answer your question, Mallory? Got it? Okay, good. Awesome. Any other questions? Those are great questions. All right. Well, that is all I had today. Here's all my contact information. Again, on Twitter, I do have my own website, SQLswimmer.com. LinkedIn, feel free to reach out. The only thing that I ask is that if you do reach out to me on LinkedIn, I'm happy to connect, but please tell me where you saw me. Being a woman on the internet is sketchy. Being a woman in IT on the internet adds an extra ingredient that not all of us want. So I'm happy to connect with you. Just tell me where you saw me, and then I'm happy to connect if you want to do that on LinkedIn. And it looks like we've got 3 more minutes, so I'm happy to answer any other questions. If y'all feel free to, put it in the chat, whatever, I'm here. And my slide deck, if you go out to my website, SQLswimmer.com, go onto the presentations page, you can download my slide deck from there if you'd like that.